Okay, this is 1.1. Just going to start going through the problems here. Number 2a. So this is saying if x is less than 0, which means if x is negative, and y is greater than 0, meaning y is positive. So x is negative values, y is positive values. Then what is x over y? Is that positive or negative? So if x is negative and y is positive, you have a negative over a positive, which means this is negative. B is x times y squared. Again, if x is negative and y is positive, when you square a positive, you get a positive. And x is still negative, so a negative times a positive is equal to a negative. And C, x minus y is over x times y. All right, so we have a negative minus a positive, and x times y, so a negative times a positive. On the bottom, we have a negative. So the top has to be negative. So for instance, you have a negative minus a positive. When you do a change, that makes you have a negative plus another negative, which gives you another negative. That's why the top is negative. So a negative over a negative is positive. Now D is y times y minus x. So we have a positive times a positive minus a negative. And when you subtract a negative, it's change. That's all positive. Everything's positive. And so those are your answers for 2A, B, and C. All right. Let's move all of that up and go to the next problem. And we'll do number 4. Okay, so you're greater than, less than, or equal to figuring these things out. So 4a is negative 3 and negative 6. So negative 6 is further left on the number line, and negative 3 is further right, so negative 3 is bigger. All right, B, you have pi over 4, and you have 0.8. So you have to get your calculator and figure out what 3.14 over 4 is. Okay, so 3 over 4 is 0.75, but pi is bigger than 3. So we have to use a calculator to figure this out. Okay, so pi over 4 is 0.785. So there you go. That's how you figure that out. C is the square root of 289, which is a perfect square, and 17. Well, 17 squared is 289, so this is an equal. So if you didn't know that the square root of 289 was 17, you just use your calculator and figure it out. All right, so let's go to the next problem. Okay, so number 6. All right, number 6 is part A, is 1/7 and 0.143. Again, to figure this out, use your calculator. But I want to give you some hints here as we get closer to some of these other ones. 1/7 is going to be something fairly simple. I want you to take your calculators and do 1 divided by 2 is 1.5. 1 divided by 3 is 0.3. And you get 1 divided by 4 is 0.25. And you get lower and lower numbers. So 1 divided by 7 is 0.1428. So obviously 1.43 is bigger. Go to part B, and we'll keep talking about 5/6. And as we get close to a whole number, like 6/6 is 1, 5/6 is going to be just under 1. Well, 0.833 is pretty close to that, but so we need to figure it out. Use your calculator, and you get 0.83 repeating, which is bigger than 0.833. Okay, because 3's just keep going on, which makes it bigger. And C, the square root of 2, and 1.4. So do your calculator. The square root of 2 is 1.41. 142, and so on. So the square root of 2 is bigger than 1.4. All right, let's move on. All right, let's go to number 8. And number 8 is, let's see here, 8a. So what we're supposed to do is just write simple inequality statements. So AA says B is positive. To say something's positive is to say that it's bigger than 0. All right. And part B, S is non-positive. Okay, so it can be negative, so less than 0, and also equal to 0, because 0 is not positive or negative. And C, W is greater than, all right, so W is greater than or equal to -4. That was a simple one. D, C is between. So you put the smaller number first, 1/5 and 1/3. And if it's between it and not equal to it, don't put any equal signs. So you put less than signs. So 1/5 is less than C, which is less than 1/3. Don't put greater than signs there. E, P is not greater than -2. So that means it's less than or equal to -2. And F, the negative of M, so negative M, the negative of whatever M is not less than -2. So it's greater than or equal to -2. And then the last one, G, quotient means division or a fraction. So we'll do a fraction bar. R and S, the quotient of R and S, so R divided by S, is at least, meaning it can be equal to or greater than 1/5. At least. It can be more. All right, let's go on to the next one. And this would be number 10. And number 10 is rewrite the number without using the absolute value symbol. Okay, number 10a. You have -11 plus 1. So they're just wanting you to solve it. So the absolute value signs are like parentheses. So let's do -11 plus 1 first. -11 plus 1 is -10. Now put the absolute value signs back in. The absolute value means that this is +10. B, you have the absolute value of 6 minus the absolute value of -3. Okay, so you do each one of these separately. The absolute value of 6 is 6. The absolute value of -3 is +3. 6 minus 3 is 3. And C, the absolute value of 8 plus the absolute value of -9. Again, treat them separately. The absolute value of 8 is 8. The absolute value of -9 is 9. So that answer is 17. All right, let's go on. And do number 12. 12a, they get a little more difficult. 4 times the absolute value of 6 minus 7. Oops, absolute value. So do what's inside first. 6 minus 7 is -1. The absolute value of -1 is absolute value of -1 is +1. So 4 times +1 is 4. 12b is 5 over the absolute value of -2. Absolute value of -2 is +2, and 5/2 is the answer. And C is the absolute value of -7 plus the absolute value of 4. Absolute value of -7 is +7, and absolute value of 4 is 4. That's 11. All right. Okay, let's go on to number 14. Number 14. A. Absolute value of the square root of 3 minus 1.7. So we need to figure this out. Take your calculator and do the square root of 3 and you get 1.7 dot, 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 minus the 1.7. All right, so leave that on your calculator, the whole screen, and hit minus 1.7, and you will get the absolute value of 0.03205. And so the answer is positive 0.03205. All right, and let's do B. Absolute value of 1.7 minus the square root of 3. All right, so I'm doing this backwards. So now take 1.7 on your calculator and subtract the square root of 3. And you'll get the absolute value of negative 0.03205, which, again, absolute value of a negative makes it positive 0.03205. And C, absolute value of 1/5 minus 1/3. All right, get a common denominator of 15. So multiply by 3 on both sides and multiply by 5 on top and bottom. So you get 3 minus 5 over 15, which is the absolute value of negative 2 over 15, which then the answer is positive 2 over 15. All right, going on to 16. Let's just add a page here, easier. Number 16. So, the given numbers are coordinates of points A, B, and C, respectively, on a coordinate line. Find the distance. So let me show you what this is showing here. 16A in the instructions says the distribution is from A to B. All right, and then 16 has the numbers -6, -2, and 4. Okay, so we want the distance. So if you were to put this on a number line, like we did in class here, -6 is here, -2 is there, and 4 is there. So if we want the distance from A to B, this was A, and this is B, and this is C, all you're doing is distance is always positive, so they're wanting the distance from -6 to -2. And to find distance, you subtract the big number minus the small number, or vice versa. So you can figure what it is on the inside. You could have done -2 minus a -6, because -2 is the bigger number. It doesn't matter, you just want the difference. So subtract the two numbers, change, that's -4 on the left, +4. Change on the right, you still get +4. So it doesn't really matter, but you subtract the two numbers it's talking about. So if you look at 18, we'll just do a simpler thing here. I'm sorry, we're supposed to go and do part B. Part B is the distance from B to C. So again, take B and C and subtract them. Doesn't matter the order because of the absolute value sign. So we get the absolute value -6, which is 6. Part C is wanting the distance from C to B. So C is 4, B is -2. That's going to be +6, change. You get 6. All right, and let's put D up here. D is from A to C. All right, so that would be from -6, minus C, 4. So the absolute value is what we're doing here. -6 minus 4 is still -10, but the absolute value makes it +10. All right, let's go to the next page and do number 18. Number 18. It's going to be the same thing, but we'll do it a little bit faster with less explanation. So we want the distance from A to B, and our numbers are 8, -4, and -1. So A, B, and C. So absolute value 8 minus a -4, that's absolute value 12, which is 12. That was part A. Part B is B to C. So that's going to be -4 minus a -1. Don't confuse the minus sign with the plus with the negative. Change. That gives us the absolute value -3, which is +3. And C is C to B. C is -1. And subtract B, -4. Change. We get absolute value of +3, which is still +3. and D. D is A to C, and that is 8 minus a negative 1. Change. The absolute value of 9 is 9. All right, moving on to the next page. Number 20. So absolute value is always kind of rough for students, but this part is really easy. So it has the values x and 7, where this is a and that's b in the problem. I'm sorry, negative square root of 2. Okay. And it says that it has to be greater than 1. Okay, so you're supposed to write this with absolute values. So you can do it a couple different ways. You can say x minus a negative square root of 2 is greater than 1. You could also say negative square root of 2 minus x is greater than 1. Okay, so they are actually the same thing, because minus and negative in the first part here is just like saying plus. So x plus the square root of 2 is greater than 1. And the second part is the exact same thing. If we move these around, x minus a negative square root of 2, you can do that. You can change the order provided you keep the same sign with them. All right, so in reality, what they're trying to tell you is you always put the bigger number first. And A, B, and C from the last examples, they go in order from smaller to bigger. So if you were doing A to C, that meant you put C first and then A. That's just how you do it, but it doesn't matter because it's absolute values anyway. So that's how you do the first one. There's a couple different answers you could have given. You could have given it like that or like this. But you just literally just put an absolute value around them, put a minus sign between them, and then say what it's saying. So on 22, you have x and 4, and it says it's at most 5. So at most means it can be 5, that means equal, but it can't be greater than, so it has to be less than or equal to 5. So x, put a minus sign between them, absolute value signs around them, and less than or equal to 5. That's all you have to do. And if you're always going to be putting the bigger number first, which this is supposed to be in order on number line, x is smaller than 4, then you should have written it properly as 4 minus x is less than or equal to 5. But again, those two are exactly the same thing because of the absolute value sign. Okay, let's do number 24, and this should be really simple. I'm just going to do it real quickly for you. I'm going to do it properly this time. It's in order, so x is actually the bigger number. It goes first, a minus sign, and then the negative 2. Put absolute value signs around it, and then it says it's not less than 4. It means it can be equal to 4 and also greater than. And to properly finish this, don't leave your answer like that. It should be x plus 2 is greater than or equal to 4. Okay, new page. Okay, so we're going to skip over to 34 and do some not basic algebra, but do some algebra here. And it wants to know if this is equal to or not equal to b plus c. So anytime you have a complex fraction, break it apart. A times b over a plus a times c over a. And now we can go ahead and cancel or reduce the a's. A over a is 1. 1 times b is just b. A over a is 1. 1 times c is c. So those two are equal. All right, let's go to 36. Number 36 is a plus c over b plus d. And is that the same thing as a over b plus c over d? Well, you can't break apart an addition in the denominator. So what you have to do is you can put that whole denominator under each of the numerators. That is a basic rule you can do. And then, is there any way to simplify these so that the d is gone here and the b is gone here? Okay, so if we look at this and do a few things, we could try to multiply the top and the bottom to get something to go away. But in reality, these are not equal to each other. Okay, now let's go to 38. And we're not trying to trick you here. Again, this is a new book. I have to look to see if there are any tricks. I know the last book really wasn't full of tricks, but at the moment there hasn't been a trick problem that I've seen. So if these were all plus signs, you could get rid of the parentheses. So let's make them all plus signs. So plus negative, or change. And then, since it's all plus, you don't need the parentheses. All right. Same thing over here. This would be plus negative c, but then you also have a negative on the outside of the parentheses, which means you have to distribute that negative. So a, and this would be then minus b, and minus a plus negative here would be a plus c, or plus positive c. So these two are definitely not the same because of the negative c and the positive c there. So not equal. All right, going on to number 40. Okay, you have negative a plus b and negative a plus positive b here. So we need to distribute this minus sign. That makes us a negative a, and that positive becomes a minus then, which if you do change, now you have negative a plus a negative b. That is not the same as negative a plus positive b. Okay, going to 42. 42 is about approximation, so we're just rounding here. We could probably use some simple math to do some of these things, but let's just go ahead and use our calculator here. 42a is 3.42 minus 1.29 all over 5.83 plus 2.64. All right, so the top, 3.42 minus 1.29, that is going to be 2.13. And then you have 5.83 in the denominator, added to 2.64. That gives you 8.47. So approximation really means, or if you used estimate, you'd say 2 over 8, that's 1/4, 0.25. Okay, that's not the same thing as approximation. So approximation is we're actually going to take 2.13 and divide it by 8.47 on a calculator. And that gives us a long value, 0.251475, blah, 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 blah. So we're supposed to go out to the 4th decimal place. So look to the 5th position, and we round 0.2515. And that's the answer. Okay, going on to 44. On number 44, we didn't do B. I'm sorry, I forgot to do B. 42 part B is pi cubed. So pi times pi on your calculator, and you get 31.006276668. Again, go to the 4th decimal place, go to the 5th one, and that's 31.0063. Okay, 44. Approximate the real number expression and express the answer in scientific notation. Okay, so this is all about scientific notation, so pay attention. 44, we have the square root of the absolute value of 1.45. That's not right. I'm going to write down the right answer, right problem here. The absolute value of 3.45 minus 1.2 times 10 to the 4th. And then that is plus 10 to the 5th. All right, so again, absolute value is the same thing as parentheses, so let's do that first. And inside the parentheses, we need to do the multiplication. So 1.2 times 10 to the 4th means we move the decimal to the right 4 places. 1, 2, 3, 4. And so now we have the absolute value of 3.45 minus 12,000 in the absolute value, and then a plus 10 to the 5th on the outside. Okay, so 3.45 on your calculator minus 12,000 is equal to negative 11996.55. The absolute value of that would be a positive 11996. 0.55 plus 10 to the fifth. Well, what is 10 to the fifth? 10 to the fifth is the same thing as 1 times 10 to the fifth, where the decimal is right after the 1, so move that to the right 5 places. 1, 2, 3, 4, 5. So you're adding 100,000 to that beginning number. So 11996.55 plus 100,000 gives me 11996.55. If we take the square root of that on our calculator, we get 334.6588,562. Again, to 4 decimal places, 1, 2, 3, 4. Look to the fifth. So that's going to be 334.6589. And that would be your answer. Except they want this in scientific notation. So the decimal needs to be moved back to the first position here. So it's going to be 3.346589 times 10 to some value. So this has to be to the positive 2, which would move this decimal 2 places back there. And that way, these two numbers would be exactly the same. All right, moving on. Let's see here. Number 46. Let's go to, let me see. Okay, 46. If a circle with radius 1 rolls along a number line, where is it after 1, 2, and 10 complete rolls? Well, one complete roll would be 1 circumference. So the circumference is equal to pi times the diameter. If the radius is 1, then the diameter is 2, so 2 pi, which is 6.283. So that would be 1 revolution. After 1 revolution, it's gone 6.283 units. So really what you're saying is the number of times it rolls times its circumference will tell you where it's at on the number line. So after 1 complete revolution, it's at 6.283. After 2 revolutions, that's 4 pi, approximately 12. That's going to be 12.566. And after 10 revolutions, that's 20 pi. 20 times 3 is 60, so 20 times pi is 62.83. That's where it would be on the number line. Okay, we're almost done. Let's go ahead and go to number 50. 50, scientific notation, 50A is 85,200. B is 0.000054. And C is 24,900,000. Okay, so your decimal needs to be where there's a whole number, one whole number to the left of where the decimal should be. Okay, so this decimal has to go 1, 2, 3, 4 places. So we write this number is 8.52 times 10. Now these two numbers have to be identical. So this decimal right here is the one that has to move 4 places to the right. Right means positive. Now these two numbers are identical. Okay, the next problem, your decimal should be between the 5 and the 4. And again, to get this decimal where it needs to be equal to that number on the left, it has to go 1, 2, 3, 4, 5, 6 places to the left. Left is negative. So you're always asking about your answer. So again, we have 2.49 times 10. And so this decimal would have to move to get back to where it was. 1, 2, 3, 4, 5, 6, 7 to the right. Okay, that's number 50. And now number 52. 2.3 times 10 to the 7th. That was A. B is 7.01 times 10 to the negative 9. And C is 1.25 times 10 to the 10th. Write this in decimal form. Okay, so all you're doing here is moving the decimal. Number 1, 7 places to the right. So 2, 3, the decimal was here. 1, 2, 3, 4, 5, 6, 7. And just fill in the loops with zeros and put commas in it. It'll make it easier to know what the problem is. So 23 million is that answer. So 701, it needs to move. Well, let's move it over because this is going to be kind of rough. So this is 701. The decimal is right here. It moves to the left because it's negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where the decimal is going to be. So we have 0.00000000701 would be the new answer. And now this decimal moves 10 places to the right. 1.25, 1, 2, and followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, comma, comma, comma. Okay. Number 54. Number 54 is just changing 9.1 times 10 to the negative, 31 to decimal form. Okay, so again, it's 9.1, and you're moving this decimal 31 places to the left. So there's 1 followed by 30 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Right. Oops. Right. There's the decimal. So, yeah, give yourself a lot of room on your paper for that one. And, oops. Let's do this. And you are done. Great job.